Okay, so I started this in a different video and then realized that there was a much easier way, so I just cut all of it out. Anyways, so we are working on paper 2, section A, number 1. And so I was looking at this, it tells you to graph in part A. So I was like, oh, I don't know how to like graph this off the top of my head, but I can make a table. But it's also calculator active, so we could like not spend all the time making a table, and we could just look at the key features on this function and calculate what those are. So what I would do, first, you see that there is a value at 0, 0, okay? You can verify that that's actually that value by doing second trace to get the calculate function, clicking enter on value and typing in 0, and you can confirm that that y value is 0. Then I would calculate a maximum. That's like the next key feature on this function. So I would get a left bound, I would get a right bound, guess, you don't have to actually guess. And 1.57, 1.718 are the values for this. This happens to be at pi over 2, which is nice. The sine of pi over 2 is 1. And so it's like e minus 1 as our like value for this right here. But you don't have to know that. You can just like go a little bit more than 1.5 and then up to almost 2 and put a point. And this is where our maximum is going to be. And then the other key feature here is this x-intercept. So I calculate the 0, and it asks for a value to the left of that 0, and a value to the right of that 0, and it asks you to guess. And 3.14159 happens to be that value, so at pi. So this value happens to be at pi. And our function, if I sketch it out, looks something like that. Okay, so it says sketch the graph of v of t, and the key thing here is the key features. You need to have these 3 points on your graph. If you did not mark those 3 points clearly, this happens to be at pi over 2, then you don't get the marks for that, okay? So +1 for having one at 0, 0, +1 for having a maximum. I don't expect you to know that 1.5 something is pi over 2. So you don't necessarily have to have that actual point, like pi over 2, comma, e minus 1 or whatever. You don't have to have that. You don't necessarily have to know that this 0 is at pi, but really, if you calculated that 0 and saw 3.141597 and didn't believe it was pi, it's fine. So +1 for marking that 0 value. But your points here don't necessarily have to be labeled, but they definitely need to be pretty accurate. So be a little harsh on yourself with this. If like your point was like way down here, you don't get that, okay? And you needed to mark at least 3 key features, the 2 x-intercepts and this maximum, okay? So that's part A, and those are the 3 marks. Part B, it says find the total distance traveled by the particle in the first 5 seconds. Total distance traveled is going to mean that you're calculating the absolute value of the function, okay? If it asks for the displacement, then it wouldn't matter. We don't have to use absolute value, but it says total distance traveled. So I could like walk from right here to the kitchen to get a snack and then back here. My displacement would be 0, but my total distance traveled is a lot bigger than that. And so we are going to be integrating from 0 to 5 because it says in the first 5 seconds. We want to stick our velocity function in there because we're integrating the velocity to get our position or distance. So e to the sine t minus 1. We must have our absolute value around this. The only way that you may have written it differently is if you figured out that the two intervals from, I'm gonna like write this out to the side. If you had the integral from 0 to 5 of the absolute value of v of t dt, and you said that that was equal to the integral from 0 to pi plus, oh, you don't have to have the absolute values in this case. So v of t dt, and then plus the absolute value, or you could have, even if you didn't use absolute value at all, you can have like the negative, because this stuff from pi to 5 is going to be negative. So minus the integral from pi to 5 of v of t dt. Okay. So either one of those, this or this, would be fine. In either case, you should use your calculator. So we would do second trace to get the calculate function, jump down to number 7, click enter. Our lower limit, oh, we need to put absolute values around this. So I want to do second insert, math, number, absolute value, and I want to stick this stuff e to the sine x minus 1 inside of that. Okay. And then we're going to calculate our integral from 0 to 5. Oops. It's going to graph it first. Now, second calc, integrate, lower limit 0, upper limit's 5. And you should get about 3.95. Okay. And this is your answer. Let me hide this guy. Okay. And so this gives you 3 marks. So I would do +1 for this answer, +1 for, I guess, the limits, +1 for your integrand, which includes the absolute value, and the function that goes on the inside. Okay, so those are your 3 marks.